website, alignment of the nodes, how to combine the nodes for displaying the symbols and so on. So you just apply these rules, and then drawing scores becomes almost fun when it was a nightmare in the in the Open Music score editors. Yeah, so that was the little commercial about Smuffle, because I thought it was really worth pointing out this framework. I'm gonna leave my presentation now and jump to some OM Sharp windows. Here, so here, how does it look like? This is a chord editor. So I'm going to just add some nodes. Let's not show anything for now. Yep. So this is a chord. You can see that all the zooming and I mean, the rendering is very smooth and I think very neat and precise, just because it follows this specification. I can zoom in out, and then it's easy to add a lot of things on top of the symbols, because you have all the information about the bounding boxes of every single thing. So you can implement the picking things at the level of the notes, the chords. We will see also on the voice and rhythmic structure later on. So yeah, let's, for instance, change a little bit some durations. The MIDI channels can be displayed in different colors. The velocities can be displayed as a value, as a symbol. Opacity for the more, I mean, all the stuff you can, all the fancy things you can put on top of a score to better display all the parameters. Daniele probably knows what I'm talking about. So all this works pretty smoothly. It's all, so there's the undo mechanism that works pretty well. And also interesting feature is the grace notes. So if you have one of the notes in a chord that's offset by a certain value, you can either just not display it and I would just hear it a little bit shifted, or I can actually shift it, or I can display it as a grace note. And so that's very nice also. And I can display these kind of notes around the chords, and it also works in more complex scores. So the only thing Smuffle doesn't help you with is to space the symbols on the time axis. So that's for you to figure out, and that's the complicated part somehow. So you must find a trade-off between the horizontal space that's needed by a symbol and the duration it occupies, the duration it takes, and there's plenty of ways of handling and optimizing that. The system we have here is not particularly smart, but it works pretty well. It just has a default weight going along with the real duration of the symbol and a minimum width that can be determined thanks to the metadata that we read from the symbol spec and the font specification. Of course, there's all the problems with symbols that take some space but don't take some time, like the measure, the bars and things like this. All this needs to be taken into account. I think this goes pretty well. Once this is computed, you can apply a factor to stretch or extend a little bit, or we can go fully proportional, which usually doesn't look so well, but can be useful when we want to display the notes proportionally. I think that was one of Rama's requests on Open Music. So yeah, if you put voices together, create a poly object, it also aligns pretty nicely, I think. Here, so we have this feature which was also in Open Music, which make every voice consider also the constraints of the other voices. That's nice, for instance, if you want to have different voices with different tempo. So now I'm going to speed up the voice at the top, and you see that the voice at the bottom sort of gets stretched to leave the space for these symbols of the voice at the top to fit in. So it also supports different time signatures and so on. One thing that's not supported yet is changing tempo in the middle of the road, which is a work in progress. Another feature that I talk about in the paper that's sort of facilitated by this new framework is the possibility to add grouping and segmentation in the score. So here we have another score. It's possible to add what's called extra in the OM or OM sharp score editors. It's all kind of objects that goes on top of the contents of the score, like special musical symbols, text, labels, markers, and so on and so on. So here in particular, we can use markers attached to specific chords in the score. So the markers follow. And then a few utilities are developed. Again, it's kind of a work in progress, but it's I will try to show how this is sort of simple to get some sub-scores according to the segmentation that's here. So here, for instance, the get segment function just allows me to display one chord sequence for each chord sequence, which was determined by the segmentation. And then I can, of course, apply any kind of processing on these different segments that I have determined. In the paper, I show the example of quantification. So I quantify all the segments one by one in order to get one bar or one sub voice for each segment, if it required. Here I have a more simple example where I will just assign a random MIDI channel to the different segments, so we can see it very quickly. Sorry. Let's do what I did before with the color, for instance. Color. So you see each sub-segment of the score has been assigned his own MIDI channel and would change each time I reevaluate. People often ask me, that's not really the point of this paper, but there's this reactive feature that works in OM Sharp pretty well integrated as well. So if I put this connection reactive, if you see it, it becomes red here, and this one as well. Now any change I will make on this score here on the top, no, sorry, on the score on the top would apply in principle to the score at the bottom as well. So that's also another thing that opens some new possibilities in all this score processing framework with OM Sharp. Like any change propagates. It's not like Max where you send the data out, it just sends out a notification to this box that it needs to be updated because something has changed on the box at the top. Last thing, and I think I will be over with time. Let me remove all the segments here. There's this little UI here that allows me to set up groups in the score. So I can select some nodes, make a group, and then I can play with group like rename, combine, align, remove nodes, and so on. And you can apply analysis to the groups. So an analysis is something that just takes what's the content of one group and applies something on it. So there's the idea here is also that you or some sort of expert user would be able to implement its own analysis on top of the score. The one that's provided, for example, is the PC set analysis. So it's a pitch class set. And I would just show you analysis that it's pretty simple. So that's the source code of it. That's it. So you define just a class. Maybe I need to put more text font, just a bit bigger. Okay. You define the class of analysis, this set analysis, you register this analysis. And then there's two functions that you need to define. One is called update analysis, where you do whatever you want with the content of the score and you have the information of the groups inside it. And the other one is draw analysis for group, and you get a group in your analysis and the position in the score editor where you need to display something. So here in update analysis, I compute this kind of circle representation of the pitch class set, and the draw, I just draw the circle. So it's just a simple example.
Thank you very much. I think time is
yeah.
Unless you have other things to say.
No.
I would leave the room for some questions.
Yeah.
Thanks,
okay.
John. It was very interesting. I do have questions. I would have like 15 minutes of questions, but that would be for some other time. Does anyone have questions for Jean?
Yes, I have a question. I have to raise my hand. Let me see.
Hello.
Yeah. I was always wondering about the duration parameter. It seems like the duration, the notated duration, and the sounding duration in open music and also other environments is always the same. In MaxScore, we have a extra parameter called hold time, which differs from the actual notated parameters. So you can actually have overlaps and polyphony. So how do you encode that, the whole time?
So in open music, and I think it's the same in Bach as well, probably. So we have this, the object I'm manipulating here, it's chord sec, so it's the equivalent of a piano roll, and here you can have overlap of duration however you want. Each note is just a MIDI, it's just a MIDI note, and the score notation is just for the notation, let's say.
Right.
In this other kind of objects that I was manipulating before, this is a voice. Yeah. And in the voice, actually, this is the rhythmic notation. And here we just don't support any overlap. So one note ends when the next one starts. There is no polyphony inside one voice.
I assume you can do polyphony by tying notes somehow, or can you have chords that are not completely tied to each other?
No, it's just not supported. Like you can tie to the next chord, but you cannot have, for instance, one note in the score is longer than the other notes.
Like, so all the chords must be tied to in order to. Okay.
You cannot even tie one note and not the other one. The chord is the minimal unit.
Is that maybe? I'm just wondering about being able to model performance aspects like legato, where we know that there's always a slight overlap to the next note, or a staccato, or other phenomena. I just, of course, I'm aware of the fact that you can have the piano roll, or the Bach roll paradigm, and you can have overlapping events. But I always felt that it was a bit limiting that you couldn't have that in the voice notation, because
it's a quite restricted representation, which is powerful in a way, because you are in a closed environment of what's the possibilities of your rhythm, and it's encoded with a tree. That's a very formal structure and quite simple to manipulate by a program, let's say. And the counterpart of it is that it's way less flexible. And if you want to do a real score notation in this editor, you quickly face this kind of limitations.
That being said, I assume you can store the data about the actual duration or overlap, as Georg said, in some sort of extras. Like you have extras, so you can have it in there and use it at playback time somehow. I mean, that's what you could do in Bach, for instance. It's true that Bach score is pretty much the same. You can have ties for single notes, but that doesn't address the issue Georg said. The performance aspect is somehow different from the representational one. But
I also noted this on the MaxScore workshop the other day, that I hadn't thought about this hold parameter that just says this just continues, like the previous, this one starts, but the previous one also continues somehow.
A little bit. Okay, thank you very much. I don't think we have time for Many more answers, many more questions. Sorry, we're 2 minutes late. It's my fault because I took 2 minutes to introduce. So this one is on me. So let's skip directly to the second paper, so to the second presentation. It's by Dominique Fober, Yann Orlarery. It's wrongly spelled, I think, in the Yann Orlarery.
Yes.
Okay, there's one additional R, I think. Stéphane Letz and Romain Michon. A web-based environment embedding signal processing in musical score. I think Dominique will present, right?
Yes.
Dominique? So
yes.
I will leave you.
I'm here. Okay. So I will start with sharing the screen. Okay, did you get my presentation?
Perfectly.
Okay, so my name is Dominique Fober. I'm a researcher at GRAM, National Center for Musical Creation located in Lyon, in France. And I've been working on an environment called INScore, which allows to design augmented, interactive and dynamic musical scores. And today I'm going to talk about its version for the web and the extensions that have been made within this framework. And in particular, the fact that it is now possible to embed a signal processing object into a score and to communicate from a native version with a set of score distributed on the internet. So I will start with a brief introduction of INScore for those who don't know, never know, and nothing better than some picture to illustrate what you can do with INScore. So here is a score by Richard Hanl. Richard has become somewhat of a specialist in pushing INScore to its limits. If you attended a Tuesday evening concert, you got an example with Unthinking Things. This score is based on December 1952 by Earl Brown. It's a good example of mixed graphic and symbolic representation. On the right, you see the original score by Earl Brown, and on the left, it's transcription in symbolic notation computed from the purely graphic version. Both are implemented in INScore. The piece unfolds a set of variations on the graphic part, transcribed in real time in symbolic notation. A second example, this is a purely graphic score intended for analysis of Turanas by John Chowning. So this score is synchronized with an audio recording of the piece, and you can interact with it by moving around in time using the representation as a control interface, or you can also dynamically change the representation. And a third example, which is taken from the GESCOM system designed by Pavlos Antoniadis, who developed a gestural approach to teaching music centered on, let's say, unplayable scores, like scores from Xenakis, Fernhof, etc. So the system is based on a simplified representation of the original score, and in which one moves in a purely gestural way. And this work makes also use of the IRCAM gesture follower connected to INScore. So this is just a small sample of what you can achieve with INScore. And there are many other works that I have not cited, in particular, the impressive work of Slavko Zagorak, who was presented yesterday. And so, and to design an interactive score, you can use any application that communicates with OSC, because the system was designed natively to work with OSC messages. But above all, there is a scripting language that allows to describe the musical score as well as its dynamic and interactive parts. This language is an extended textual version of OSC enriched with variables and programming capabilities. Here is an example that concisely illustrates the results that you should see now. So let us now come to the heart of my presentation. I will quickly present the main lines of this work in order to have time for an online demo. And for the details, I invite you to read the article. So get ready for the online demo in which you will participate. I just want to copy some links into the discussion tab, but I can't find it anymore. Probably because I'm the speaker.
Can I help you in any way? Perhaps not.
I'm just looking for the discussion tab and I can't find it anymore.
It should be when you should have ... and there's the chat. Do you have the ... in your bar? In your Zoom bar? Not really, because
so it does.
You can send it via email to me, and I will post it on the chat.
Okay.
It's going to go twice around the world.
I will send it by email to the first person that I will find in.
Yes.
Okay. Just. Maybe Jean, because Jean is
reliable.
Not more reliable than you.
Exactly. I would have said the same thing.
But, I'm more used to communicate with Jean, and so it's more easy to find its email address.
No hard feelings, don't worry.
Okay. That's done. Jean, you should receive the links. So I will now present the technology implemented to port INScore to the web, as well as the extensions that have been made, thanks to this new JavaScript architecture, in particular, the integration of signal processing object based on the Faust language and compiler. So INScore is based on model view controller architecture. The model is based is an abstract representation of the system, and the view is a graphical representation of the model. This type of architecture makes it possible to replace one view by another, or to have several different views of the same model. The controller is in charge of modifying the model. In this case, as INScore is a message-based system, it takes messages as input and to create or modify objects in the model. It is also in charge of refreshing the view, which in this case is done at periodic time intervals. And in its native version, the view is based on the Qt framework, and all these components are compiled into a single application. So WebAssembly technologies have provided us with an optimal solution to deploy the model in JavaScript. The model and a large part of the controller are compiled in WebAssembly, WASM for short, with mscripting tools, and the view has been redeveloped in JavaScript by addressing directly the document object model. So the part of the controller that lies in the JavaScript library is only in charge of activating the time task. So in general, the architecture of a web page is an architecture of components, often distributed. The web page can refer to remote resources and also use remote libraries or style sheets. And this is also the case for an INScore web page, which uses the Guido library for symbolic notation, the music XML library, both developed at Gram. And this component architecture has made it possible to integrate the Faust library, still a Gram project. I will not present Faust. It would take me much longer, but in a few words, Faust is a functional, synchronous, domain-specific programming language working at the sample level, designed for real-time audio signal processing. And Faust program can be efficiently compiled to a variety of target programming languages, and notably to WebAssembly. For more information, you can have a look at the Faust website or go to the Faust integrated environment, where you can try the system online. The integration of Faust into INScore has been triggered by the fact that the Faust JavaScript library provides a high-level API to directly transform DSP code into a web audio node, thus solving all the architectural problems that can be encountered in a multi-platform environment. Forced objects are first-class objects in INScore. They have a temporal dimension like all others and can be seen as a block diagram. So the DSP code is compiled on the fly using the embedded compiler, and the forced object automatically extends its address space to provide an interface to control its parameters using INScore messages. Finally, forced objects are connectable to any audio node, audio input, output, and audio or INScore audio or video object or other forced object. Therefore, you can construct an arbitrary graph or INScore object for signal processing. So let's go to the communication scheme. INScore was natively designed to communicate over networks, and its first control interface was entirely based on OSC messages. And INScore has been providing a forwarding mechanism for a long time that allows all incoming messages to be redistributed over a local network. So this mechanism has been extended to the HTTP, HTTPS, and WebSocket protocols. Unlike OSC, which is transported over UDP, a connectionless layer, these protocols require an established connection between the computers that want to talk. Thus, a specific message is therefore used to establish this connection. So I invite you now to go to the following page, but I see that I think there are already many people connected, but preferably use Firefox or Chrome, but not Safari or Internet Explorer. With Internet Explorer, it doesn't really work, and with Safari, it's a little bit complex. You have to adjust your preferences to get sound and so on. You can also use your mobile phone unless it's running iOS. So you should see the following page. It's part of a piece from Jonathan Bell. Thanks, Jonathan. Implemented using images, a cursor, the red vertical line, an audio file, which you don't see, a forced DSP also hidden, and buttons to play the score and the audio. At the bottom left, you have a connect button that triggers a connection message to a native version of INScore that runs here on my computer. And you can play the score and move the cursor by clicking on the score and so on. So building an INScore web page is quite straightforward. You have to include the libraries you need and to have to include a special div, special because its class must be INScore and it must have a unique identifier which will be used as the name of the INScore cell. You can then put any valid INScore script into this div, and that's it. So now I invite you to click on the connect button, but I think there are already some people that did it. Okay. Audio input is not required. So if your browser asks for permission to use the microphone, just say no. On my local computer, my score is a little bit different. It does message forwarding in HTTPS, and it has additional controls that will send messages to the connected remote host. Just wait for, so there are already 11 people connected. I guess, okay, let's go on. So here I will do, for example, I can show you the block diagram of the forced DSP. Actually, it's a stereo echo, no more than that. I can play the score for you. Browse the pages, and you should have exactly the same behavior on your computer than on mine. So let's play, and I will now connect the echo. I can change the echo parameter, for example, the delay, the feedback, I disconnect the echo now. And it's quite disturbing to make such a kind of blind demo because I don't know what happens on your computer. So, but I guess
it works.
I will have some feedback after that. So you get the ID, well, so the INScore package for JavaScript is recently available on NPM. You can find the link on the INScore website. It includes examples of pages to make your own score. I just show you briefly how to do that. But there is a simple solution, still experimental but promising. I invite you, I invite you not. I will go for those who are connected. I will now take you to the next page. If it doesn't work, you can also click on the link that should have appeared in the first demo. So this is, for the others, the link is the second one sent in the discussion tab. So you are in the online INScore editor, which displays one of the examples provided for illustrative purposes. Here you can click on the play button or on the blue square to interact with the system. And the corresponding script is located in the editor on the left. And now I invite you to go to the Save menu on the top of the page and to choose as HTML page. So you should then find a file called syncframe1.html in your download folder. And you can open it in your browser and interact with the score in the same way. The page is completely self-contained. So I should just point out that there are some limitations to this, which are the following. It doesn't yet work with Faust objects included in your score, nor does it work if the score refers to files that are on the server. So the web deployment of the INScore engine is an ongoing project started 4 years ago in parallel to the native version development, and the design issues encountered in the past were solved by the evolution of languages and compilation technologies, allowing us to support various platforms from the same source code. So the web version of INScore opens new perspective, particularly relevant in the context of this crisis where the web has taken a central place. Distribution of musical work involving electronic parts has never been straightforward. Being able to publish such works on the web, to make them available without prior installation, ready to be played for home, may constitute an essential tool for the dissemination of contemporary creation. Remote control could also open new prospects, both from educational point of view or for the rehearsal and the performance and the music. And regarding the future work, there are still many things to do, but among the interesting direction, providing a bi-directional communication with WebSocket could open the system on new uses. MIDI support is also planned and in progress. Many musical pieces use MIDI to trigger events, and this will allow them to be fully implemented. So that's all. In fact, it's a bit disorienting to do a blind demo. I hope that everything went well on your side, and thanks for your attention, and I'm ready for questions.
As far as I'm concerned, it went flawlessly. So thank you very much, Dominique. It was very pleasant. We don't have time for questions, though. You took 20 minutes. No, we maybe have time for one quick one. If someone has one quick question.
Can try to make a quick answer.
Exactly. Everything under 1 minute, let's say.
I have, it's not really a question, more just I was really impressed with the sound quality of the, in the browser, the real-time response and everything was, and all of the changes you were making. I was, yeah, it was super impressed with the quality of the sound. So yeah.
It's Faust.
Wonderful.
Yeah.
But I mean, the whole JavaScript version of it and everything, I mean, it works just really well. It's very cool.
Okay, thanks. Just one final remark. First, this is first an alpha version of the system, but if you encounter some problems to connect and so on, please send me your feedback. You should find my email. I don't know where, on the paper. Yes, on the paper. Send
Probably
me your
at the
feedback
top.
and with details about if you have some about your problems.
Thank you very much, Dominique.
Yeah.
Sorry, we have to move on. I'm the bad guy. I'm sorry. We move on to the next presentation, which is the last one for this session. Let me welcome Paul Grünbacher, Rudolf Hanl, and Lukas Linsbauer. They will talk about using music feature for managing revisions and variants in music notation software. Paul?
Yes, welcome everybody.
Thank you very much.
We're very glad that we can present our work here at this conference, and we are learning a lot from the community. My co-authors are Rudolf Hanl and Lukas Linsbauer. Rudolf is also in the audience today. So we are actually coming from an engineering discipline, from software engineering, and we got interested in applying some of our methods in the field of music notation. And that's what my talk will be today. So on the first slide, I want to present some basic terms we use in software engineering. If we talk about revisions, we essentially mean sequential versions. So that's very common if you have some, some initial version of some music piece, as in this example, you may start up with the setup and the notes, and then the music engraver may add slurs and dynamics and lyrics, and maybe later some texts and articulation. So you have really a temporal view of what's changing. But there are other kinds of versions which are actually variants, and the variants are seen as concurrent versions, and very often they are intended to stay longer. And for instance, you may have for this piece a French edition, and for the same piece a German edition, and both are actually relevant, and you need to manage them somehow. So yes, so we have to deal with the issue of evolution in time on the one hand, and evolution in space on the other hand. There are version control systems around that support you for doing that. You can manage any kind of digital artifact with version control systems. There's one group of version control systems, they're called the extensional version control systems, and they basically allow you to retrieve again what you committed before. Like if you think of systems like Git or Subversion or Mercurial, you can commit a snapshot of your project, and later you can retrieve that snapshot again. So that works pretty well, but it has also some downsides, because what you can't do is that you cannot compose new versions of what based on what you committed. And that's what the intentional version control systems are for. They are also called variation control systems. And here the idea is you can compose new versions based on features of already committed versions. Like in our example, we have features like setup, notes, slurs, dynamics, lyrics, text, articulations. And it would be cool to say, well, I would like to check out a version of my score that has only setup, notes, and dynamics. And the system would then give me exactly the score with those features. There are systems that allow you to do that. Two examples are LilyECCO and Supermode. So they aim at uniformly handling revisions and variants. So we've been working with variation control systems in a different domain of industrial automation software, but we are music enthusiasts, so we got interested, can we apply that also in the area of music notation? So the important term here is a feature. What is a feature? It is something that is important to a stakeholder of the concept. Well, we were wondering what could be a music feature. Well, a music feature could be anything like, stuff, voices, lyrics, slurs, articulations, dynamics. It depends on who is working with the system, what is a feature. That was just, our first attempt to dealing with music features. So then we said, what else do we need to make this work? So in the talks before, we already heard about some system like OM Sharp and INScore and so on, and they use some music artifact formats. So they somehow this music information is encoded. We are working with LilyPond, but as you all know, there are many other ways how you can encode music. The big thing here is that current version control systems like Git, for instance, they work at the level of individual lines. So they essentially, they create a diff, a line-based diff, but that doesn't work for music artifacts where you need to pass at the level of individual elements. So for instance, in LilyPond, C4 means that C is a note pitch, whereas 4 is a note duration. So you cannot work at the level of lines. So that's what we had to consider when we built our LilyECCO variation control system. So what did we do? We took an existing variation control system, Echo, and extended it first with a LilyPond reader. So we took a parser for LilyPond code, which can create an abstract syntax tree and then creates the data structure to manage basically the snippets of the scores and their relation to music features. So then a music engraver can start committing scores, like here, for instance, a first commit. The things marked in yellow are actually the new things. Like here, after committing the notes, the engraver would add the slurs. So as you see, this beginning of the phrasing slur and end of the phrasing slur is not in the same line, it's in different lines. That's why you need the specific parsing. Then we add the dynamics to the system. We add the lyrics to the system. Again, you see the differences that are computed. And then this allows us to, well, ideally check out some new variants of that score by just listing the features, notes, slurs, dynamics, lyrics, and so on. We have another plugin, a LilyPond writer, that then takes the artifact tree that is composed for this variant and again produces LilyPond score, which can then be compiled to create that particular variant of that score. Or of course, you can generate PDFs and media and so on. So that's what we did technically. So of course, we were interested, how well does it work? We first had some mini examples, then we looked at a larger piece by an Upper Austrian composer. It's an a cappella piece, and we got interested in two aspects of the work. Does LilyECCO compose correct music artifacts? So essentially, does it work? Can it produce different variants? And the second research question, is it sufficiently fast? I mean, there's a lot of computing going on in the background. So is it also fast enough for large music artifacts? Our data set had two parts, 6 voices, about 2,000 note pitches, about 1,200 note durations, 1,500 parts of lyrics, and so on. So it was reasonably complex. We looked at the score and identified music features. We didn't have an evolution history for this piece, obviously. So what we did, we deconstructed the full piece, removed feature by feature, and then started again from scratch and added one feature after the other to this piece. So this gave us a data set for our experiments. And we had a script automatically committing the 52 features of our data set to LilyECCO. Regarding correctness, we looked at both intentional and extensional cases. That means basically versions that had been committed before and versions that had not been committed before. We also looked at the resulting scores. First, of course, we checked, does it compile? Are there any syntax errors? And then we also looked in our environment at the music to features and music mappings. Regarding performance, we measured the runtime of the commits because this is the most expensive operation actually. So here are some examples that are also reported in the paper. The kind of smoke test was to recreate the full piece again by checking out all features of the score. That worked, luckily. Then we extracted the soprano voice and additional features of the voice, like dynamic slurs and text and so on. That also worked. Then we did another thing. We said, let's extract the soprano voice only of part 2 of that piece. Here we then generated the code. Then we got a syntax error. We inspected the code and realized that LilyECCO gave us actually more code than we needed, because there was a case that 2 features could not be separated. Essentially, this was very easy to fix because the compiler pointed it out to a LilyPond line of the score. We just had to remove, and then it compiled. So this is the normal workflow, actually. If you have a feature interaction that 2 things never existed before together, you can quickly fix it and then commit this new variant again. And from that time on, LilyECCO knows about how those 2 features interact. And well, another case, just extracting the soprano notes also worked. So yes, we got some good results regarding correctness. There are some minor fixes needed, but we are only in the beginning of the experiment. So there's a lot of work that needs to be done. And the performance, well, generally, we would say it's okay, but there's also something that needs to be done. The average time to commit a version was about 6 seconds, but if the number of features grows, this can affect performance. So we will also need to look into that. Yes, a summary and maybe some discussion of future work. I mean, what we tried to do was to develop an approach that allows to manage both revisions and variants of music artifacts. The approach uses features to structure and compose music artifacts. Features are cross-cutting. They are not located in one particular part of the score, but they're actually cross-cutting, as you have seen in the LilyPond examples. And we think there's a lot that could be done, and we are very happy if the TENOR community sends us some idea or wants to try out something. So for us, of course, it's interesting what constitutes a music feature. I mean, it depends, as I said, what you want to do with the score. And depending on that, you will have to define your features. So it could be interesting to see how different people would define features. And this would also mean, it could be interesting to do user studies on how, what the preferred workflow of music engravers is if they work with that system. In our initial experiments, we worked with a cappella music. We have also some other examples, but we need to do more experiments with different kinds of music. That's obviously also an area. Then, of course, variation control systems and version control systems are to support a team of people working together. And so far, we didn't look at the distributed engraving scenarios where you have multiple people working together. And I mean, our technology-wise, what we can do is to support feature-based cloning and pulling. So actually, you could create another repository based on an existing one by selecting the desired features, or you could pull one music feature from one repository to another one. That would be possible, but we didn't test it so far. Of course, one issue, and that's another area where I think work would be needed, is usability and cognitive complexity. That's generally the issue if you have features which are mapped to a complex artifact. Then, I mean, the feature to code mappings can become complex, and having ways to present that to users in an adequate way is another area of interest. Yes, and as I said, finally, there are possibilities for improving our approach regarding the performance. And I think 2 reviewers have asked us about, okay, does this also work with other music notation systems or formats? The answer is yes, because you can provide plugins for your language. Essentially, you need a parser for your language, and then you can provide that plugin to ECCO, and you have support for your language. But again, that has not been tried out. So far, we worked with LilyBond as we knew this best. Yes, I think that ends my presentation. Thank you very much for listening. And if you have any questions or want to get in contact with us, just email me. Thank you.
Thank you, Paul. Thank you, Paul. Wonderful presentation. I personally think we will need Git-like, versioning system for SCORE more and more in the future. So it's, I feel like it's the beginning of something we will explore more in depth, perhaps in future years. Thanks a lot. There's one question in the chat. Someone asked, Ami asked if the project was already online or.
The basic system ECCO is already online. We are also planning to make LilyECCO available online, but we need to still do it. But that's our plan to publish it as a plugin to ECCO in the ECCO repository.
Then there's a question of Todd, who raised his hand. Perhaps Todd, you want to?
Hi, thank you. Hello, everyone. Yeah, wonderful. Thank you. The group engraving concept is absolutely relevant. Last year, a whole team of us in Lübeck were hired to very quickly, as possible, convert a Prokofiev opera for a publisher in Hamburg. And so this was probably very relevant to this publisher, and for containing and controlling many versions which are coming in at the same time by a whole team. So I think your project has a lot of potential and relevance. Thank you.
Thank you very much. Yeah, that's something we are certainly interested in. That would, of course, require some technical work, but also user studies to understand, what would be the best way of doing that, and how people would work with music features, and what features you would define for a larger piece, and so on. So I think there are many questions I would be very interested in. Yes. Mm-hmm.
If you would like the name of the publisher, or, well, I'm sure you can find publishers too. When you're ready, then you can ask them what they need and what they would like.
Okay, yeah. Thank you very much.
Thank you.
Does anyone have one more question? I saw someone with a raised hand, but I think they lowered it, perhaps, or they're no longer in the participants, I think. So perhaps if someone if no more questions, then I think we can end here. We're exactly on schedule, so 11:15. Now we get to a 15-minute break, and then at 11:30 there's a new session. So see you at 11:30 for Common Practice Notation. Hello to everybody.